Unpeeled. Today, we're going to talk about how to clean 3D printed hydraulics, a 3D printed wash basin or sink, and also a new 3D printed bridge by Zaha Hadid Architects. So first, Domin. Domin is one of my favorite 3D printing startups. I love them. They're a British company. They make 3D printed hydraulics. They sell these things right up against Bosch, Parker Hannifin, Moog, and they make actuation devices, actuators for aircraft, for cars, and for other kind of high-end type applications. And the cool thing about them is they make them 3D printed. Now, of course, 3D printed these kind of complex devices, you can get better flow, you can reduce mass, and you may overall be able to increase the performance, definitely per gram or per cubic centimeter as compared to other kind of hydraulics components. What is the cool thing is because of Domin's design and manufacturing prowess, they can actually sell these things that are quite cost competitive with conventionally manufactured hydraulics units. So this is absolutely fantastic. Now, what they've done now is they have developed their very own powder evacuation technology. So essentially, if you do powder bed fusion, which is the technology they use, you're going to have powder. You're going to have to come up with a support strategy to optimally print your part or your collection of parts to keep it from ripping itself apart. And you're going to have this unsintered powder that kind of acts as a support and kind of also fills up the interior of your model. And of course, that has to be removed. If you have a very simple kind of a cylinder kind of shape, it's going to be really easy to do that. If you have a really large shape of maybe one cavity, then also maybe you put it in a machine that kind of turns everything around a couple of times, and it's also going to be really easy to do that. But of course, if we're looking at Domin and what Domin makes, they make actuation components like the one you see in front of you, which has a bunch of little channels inside of it. And you can already see that this is going to be quite problematic. You're going to have these small little channels everywhere. Powder is going to get trapped inside of these channels. Now, so of course, especially if they want to go continue doing this, making more intricate and smaller units or more complex units, and this is going to be a problem. So what the company did is they developed their own powder extraction technology. It's basically the entire build platform goes in some kind of machine. They're kind of vague about it. And there's a 2-axis kind of continuous vibration machine, which shakes loose the powder and gets it out. Now, of course, if they have a lot of similar components, they can do this, program this really specifically for a specific type of powder, a specific build platform, and a specific even set of channels or type of problems that they usually encounter. The company says this takes 10 minutes and that they've solved this problem. Now, normally you would have to do this manually, which is dangerous because this powder is loose and can get in. You have to protect yourself against it. Loose powder can also explode in certain cases. And it's just costly because you need a person there to get this powder out, or you need to buy a different unit that has just been optimized, like a silicone unit, but that's just been optimized for really large parts, like space parts and stuff like that. So I love this because now we're seeing that Domin is using its process knowledge to, at the really, really kind of like the pressure points in this technology, is developing technological solutions. Now, if you're a Moog or a Bosch and you're competing with them and you also want to 3D print, you're going to have to also develop your own powder evacuation technology, or you're going to have to be able to come up with something that's better than that, or have a vendor that has a better solution. Everyone has the same machines. Everyone potentially could have the same powder. Everyone could have similar designs. But if all things are equal, then Domin will still win because they do this powder evacuation step in a more efficient way. I think this is wonderful, and I think we're going to see more and more of this process-driven competition with people. I think it's absolutely fantastic. So really, really cool. Next thing is from Zaha Hadid Architects, which they've done a bunch of 3D printed stuff so far, and now they've worked on a bridge, a 10-ton bridge called the Phoenix. Actually, there was an earlier bridge, the Stratus, and this is like the Phoenix. Now, this bridge has 25% less CO2 than the previous 3D printed bridge. They printed it in Lyon, France, on Holcim, the manufacturing or the concrete company's innovation hub, and they work with the Block Research Group, which is led by Philippe Block at ETH Zürich, and Incremental 3D. Now, the wonderful thing about this bridge is I think like a lot of these architect-driven kind of things are usually kind of fanciful and kind of silly, right? And they're kind of design-driven and they're not exactly very useful. This, as you can see, is a 3D printed bridge, but it's made out of different blocks, right? And that means it can be disassembled. So this could be a temporary bridge, or this could be printed in a factory and shipped into place, or it could be kind of a very kind of modular type bridge that could solve a lot of different solutions. So I love this as being, if we're seeing across Europe, for example, a lot of infrastructure across Europe has been temporary or has been put in place in the 50s after the Second World War. There's a huge infrastructure boom in Europe, and a lot of concrete, cement, and kind of like very kind of automated, very cheap type of structures were built back then. Now we're talking already, depending on when this building boom took place, is different for different countries, for different things. We're talking about bridges, a lot of small bridges, a lot of parks, and a lot of sewer infrastructure and that kind of thing. This stuff is 70, 80 years old. And we don't make concrete as well as the Romans did. So our stuff doesn't last that long. So the market for a really high volume, designed to fit, kind of cookie cutter, if you will, bridges and stuff like that is huge. And I think this could actually be a solution to make a bridge that is configurable to a certain extent, that works and that will pass inspection and pass the functional requirements in many different cases. So I really like this. I think this is much more than just some kind of cool, fanciful, architect-led kind of design study thing. This is something that you could really see taking place in a park and all that kind of. I don't know if it works, right? It may be too steep. It may not work very well. But hey, I love this so much more than a lot of other stuff. I love the fact that just because it's 3D printed doesn't mean you need to make it all out of one thing. In this case, this arch structure could be really, really strong, and you could make these individual parts so strong by clicking them into, in effect, a kind of an arch structure that could provide the same strength and make it a very, very kind of common and easy to do thing. So I like this very, very much. The next thing is Kohler. Kohler is a Wisconsin-based company. Started in 1873. They make sinks and a whole bunch of more stuff. It's a 40,000 person company, and they've gone a lot more outside of where you would expect like a regular sink manufacturer to go. They've got like an IoT lab. They sponsor, I think, Man United. They've also done 3D printing. Now they've reportedly come up with their own 3D printing process for this. I don't know if they did it by themselves. I don't know how mature this is. I don't know. Maybe they contracted it out to someone. I have no idea. It combines some kind of traditional process with some 3D printing process. Now, they used to have this Rock 01, which is a very architectural kind of thing, which is super limited edition. And now what they're doing is they're putting the Rista 3D printed sink on the market. Now, this is 3D printed with vitreous china. You're like, vitreous china, what is that? Vitreous china is the kind of that shiny, hard material, the kind of enamel-like material. It isn't actually enamel, I think. That is a ceramic material that is very, very common in sinks and toilets and all these other things. This is a material that lets you spill things on them and then they don't stain. It lets you clean them thousands and thousands of times for decades. And that's really kind of like the secret, if you will, to a lot of toilets and a lot of other kind of similar things lasting that long. And this, apparently they've constructed a 3D printing process for this. Now the sink still is frightfully expensive, I think. I don't actually know how expensive sinks are, but this is $1,300 at the moment. So that's, I think that's quite a bit for a sink. I don't know, but maybe I'm wrong. Maybe sinks are much more expensive than I thought. But I like that this is a product. I like that this is a product that's on the market. I like that this is becoming much more accessible than this Rock thing, which is more a Rock 01 thing, which is more of a design study. And maybe this is going to be something that they roll out. I like 3D ceramics a lot. I think that's a future where we could see a ton of more commercialization. And I've been following that for a while. So that's really good. Now, so that is the news for today. My name is Joris Peels, and this is brought to you by 3dprint.com. I hope you found this useful in some way. Have a great day.